So hello guys, today we are going to do a lead code question that goes by the name Reorder List. The question number is 143 and it's a medium level, like medium level question. Okay, medium level basically with the medium level also consists of medium easy, medium and medium hard. So it is basically a medium level question. Okay, medium level question. So we'll first try to read the prompt statement, then we'll go to the solution eventually. Okay. So what are we given in the question? Okay, we'll start by reading the problem statement. You are given the head of a list, singly linked list. The list can be represented as L0, L1, L2, Ln, and this is that is how your array is also represented as. Okay, L0, L1, L2, L3, L4, and so on. Okay, so you have to reorder the list such that L0 till Ln, then L1, then Ln minus 1, L2, Ln minus 2. Basically, okay, you have to order it like this and you have to modify the value. You cannot modify the values, you have to rearrange the nodes. Okay, I'll try to explain you what the question is saying. What is the question trying to say? Basically, if these are the nodes, these are some of the nodes that you have. Okay, if this is index 0, 1, 2, 3 and 4, or I can name it as 0 and then n minus 1, this is 1 and this is 2. Okay, so let it be, or this can be presented as n minus 2, this can be presented as n minus 3. Okay, and basically n minus 4 or n minus n, so this will be 0. Okay, so basically n is 4. Okay, so we are getting it as 1 and we are getting it we will get it as 4. It is as simple as it looks. Okay, so you are given this array, you are given this linked list, okay, you have to arrange it in such a order such that the first node is connected with the last node, then the last node, basically the first node is connected. Basically I have to rearrange the linked list such that my first node is connected to the last node, my last node is connected to the second node, my second node is connected to the second last node, and my second last node is connected to the second node, this second index node. Okay, this first index node, then second index node. Okay, so if you are given like this, if you are given something like this, A, B, C, D and then E, okay, you are given an order like this, you have to rearrange it in basically first comes the first element, then the last element. You have to pick one element from the first position and one from the last position and basically join them. So first node would contain A. Okay, first node would contain A. Okay, if I place a pointer here and a pointer here, okay, first node would contain A, so A is joined. I'll just move this pointer, I'll take this now, so E will be joined. Okay, I'll move this pointer here. Okay, so in this B will be joined, then B will be joined, then C. Okay, then D will be joined, then this, and then C will be joined. Okay, so this would be the order that I have to make. Okay, so you have to connect the first node with the last node, second node with the second last node, and third node with the third last node. Basically for every node, basically if first is a node, you have to connect it with nth node. Okay, for second node you have to connect it with n minus 1, third node you have to connect it, second node n minus 2, first node n minus 1, zeroth node with n, third node you have to connect with n minus 3 and so on. Okay, 0 with n, 1 with n minus 1, 2 with n minus 2. Okay, and it is in an order. What is the order? Like this. If I follow the order how it should be connected, so it be connected like this. Okay, so this would be the connection order. Okay, now I got it how to do it. First one element would be from the first and one from the last. Okay, so how can I do this? Basically if you are given a linked list like this, 1 2 3 4 and then 5, what can be the brute force solution? Okay, brute force solution. Okay, you can basically store them in a vector. 1 2 3 4 5. Okay, and you can arrange them in a new vector. Such that First the first element comes, then the last element comes. Okay, you can basically use two pointer techniques to get them in order, like this and then this can be the order that you can get, and you can again store them in the linked list. So my linked list would be overwriting the values, and my linked list would be like this. Okay, this could be the possible solution, if we could manipulate the values. Possible solution if we could manipulate the values. Okay, but it is strictly written that you don't have to manipulate the values. You may not modify the values in the linked list nodes, only nodes themselves may be changed. So you have to move this node. You have to move this node in the second position. You have to move this node in the required position. You have to move this node in the required position. Okay. So if you are given something like this, basically 1, 2, 3, and then 4, I have to make it like this. First from the first position, then this comes here, this will come here, this will go there, this will go there. Okay, so nodes would themselves move. You cannot modify the values. Okay, so how will I do that? How will I do that? Okay, if you say that bhaiya, it is not difficult. If it is not difficult, okay, I'll just place a pointer here, place a pointer here. Okay, and as you said that we have to take first from this node, and then from this, then from this, then from this. Okay, basically first, then n minus 1, then second, then n minus 2, then third, then n minus 3. Okay, I'll just simply do it, and I will, for every iteration, I'll just move my forward pointer here and my backward pointer just one position before. Okay, but no, if you carefully see, all the nodes are connected in the forward order. Okay, this is a singly linked list. So the pointer can move forward. Okay, but the backward pointer, once it has reached the last position, it cannot come back. The moment is restricted. You don't have the address for that particular position. Basically, if you have to go from Gurgaon to Faridabad, okay, there would be many stops in between. Okay, you are going Faridabad for the first time. Okay, and the second person that is leaving you already knows the address. Okay, so if you would reach Faridabad and I say that you tell me the previous stop that came. Okay, you have to go to the previous stop that you came. You are not listening. You are not like storing the address. You are not remembering the address from which route we came and which are the nodes that we followed. You just came. Okay, trusting the other person, you just came and didn't saw anything. Okay, so you don't know about these values, and you don't know about these values. Okay, you can't iterate over them again. Okay, you can't go back to them again. Okay, so what can be the solution? If my second pointer cannot move back, what can be my solution? Okay, if I try to tell you, if you look carefully, okay, this is my list. If this is my list that I want to manipulate, okay, I have to print it in an order such that first node comes first, then this node. Basically, if I just write them in the order of printing, so first this would be printed, then this, then this, then this, and then this. Okay, so as you can see, we are basically taking the first index, then the last. Okay, basically you are taking one from the starting and one from the last, then one from the starting, then one from the last, then one from the starting, and then one from the last. Basically one from the starting only, at this the iteration ends. Okay, so if I get a data structure, that would store all the nodes in the particular order. Okay, in the particular order, basically the order that is given, and I can remove the node from starting as well as end, from start as well as end, okay, as well as end, okay. So if I get something like this, basically if I tell you 1 2 3 4 and 5, okay, basically if something like this I have, this is my data structure and it is storing all of my nodes, basically first node, then second node, then third node, then fourth node, then fifth node, okay, then fifth node, okay. So this is my data structure. What I can do is I have to get access to the first element first, then the last element, then the second element, then the n minus 2, then the third element, then the n minus 3 element, okay. So what if I say you, if there exists a data structure, if there exists a data structure that I can first take my front value, I can first take my front value to make something to get the first node, okay. So my data structure would be something like this, okay. Then I would just take a value from the back, take a node from the back, and I'll push it to the list, okay. This node would also be deleted, okay. Then I'll again take a value from the front, then I'll again take a value from the front, then I'll again take a value from the back, then I'll again take a value from the front, okay. So can I do this? Can I do this? Is there exist any data structure like this? Any data structure like this that can allow me to pop from both the sides, from both the sides, pop the nodes from both the sides, get access to the nodes from both the sides, basically from the first position as well as the last, okay. Is there exist any data structure? Yes, you are right, you are right. Deque, basically what is deque? It is a doubly ended queue, doubly ended queue, okay. So what is a doubly ended queue? If you know the concept of queue works on the principle of first come first serve, okay, first in first out basically. So one that comes first, if these are my nodes, okay, if these are my nodes, if it is a queue, I can remove the nodes only from this, like only from one side, okay, only from one side, okay. So this, then this, basically putting this, then this, then this, then this, then this, okay. These are the values. It can be removed only in this order, from the starting to the last. But if I take a deque, all the elements, can be basically, popped out and given access, to the elements, all the elements can be basically popped out and given access to the elements, okay, from both the sides, okay, both the sides. So yes, you are very close to the solution. So if this is my linked list, suppose 1 2 3 4, and if I store it in a deque where I can basically take it out from any of the indexes, any of the side, like front and back both, okay, like front and back both, okay, sorry, front and back both. So first what I can do, I can just simply extract the first node from this. I'll put it in the first position, okay. Now my queue becomes something like this: 2, then 3, then 4, okay. So my first position is done, okay. Now it is my even position, so I can basically like take a index like 0. I can start from 0 and I can alternate between, I can switch between from where I have to pop, be it the front side or the back side, okay. I'll take the first operation to be from the front side, because I want the first node to come at front, okay. So first it's at the first position, okay. Now this is my queue, this is something like my queue, okay. I'll pop the last, pop from the back. So 4 is popped and it is pushed into the list, okay. So 4 comes here. Okay, now what I have to do, my I becomes 2, I becomes 2, it was 0, then 1, then 2 now. Okay, so I'll pop this, okay, and I'll push it into my linked list. Okay, so 2 also becomes empty. My DQ only contains 3. I'll pop from the back, my I is equal to 3, I is equal to 3, I is equal to 3 now. I'll pop it, okay, and I'll push it here. Okay, so this is what is something gonna be my answer. Okay, and this is my first test case 1 2 3 4. What I am getting it as 1 4 2 3. Okay, so this was the solution. Basically, I am using a DQ. Why DQ? Because it will give access to me. It will give access to the front nodes as well as the back nodes. Okay, so I don't need any pointer, to give me the access. Okay, if I consider this test case, 1 2, basically not 1 2 3, I'll just consider it like this. 5 6 7 8 9. Okay, so 5 6 7 8 9, I have to first push this. I'll push all of them into DQ. So my DQ becomes something like 5 6 7 8 9. Okay, my I is currently 0. What I'll do, I'll simply, for I is equal to 0, I'll pop from the front. Okay, so first node is 5. Okay, it is popped. Okay, my I becomes 1. For the all the even numbers, basically as I'm starting from 0, for all the even numbers I'll pop from the front, and for all the odd numbers I'll pop from the back. As you can see, as I have to get the first element first, so I'll pop from the front on even, and I'll pop from the back on odd. Okay, so for I is equal to 1, I'll pop from the back, so it becomes 9. Then I becomes 2, so I'll pop from the front. Then 6 adds to the list, I becomes 3, so I'll pop from the back. 8 comes to the list. Okay, then it becomes 4, I'll pop from the front. 7 comes to the list. Okay, so this is what I'll get. Basically, it was a very easy solution, right? Just use a DQ, get access to the back and the front elements, and basically alternate between the front and the last position. Where to get the node from. Okay, this was the algo all about. If I try to code this approach, also there are two test cases, the edge cases you need to take care about. Basically, if there is no node, if there is no list node at the start, okay, I'll simply return, because if there is no list node, there cannot be any reordering. Okay, and if there consists only one node, only one node, it is already sorted, it is already reordered. Okay, anything cannot be done, so it will be returned as it is. Okay, so I will add two test cases, head or head next. Okay, not of head next. I'll simply return. Okay, I'll add a DQ of the list node, as this will give me access to the nodes rather than the values. I'll just make a list node temp that will point to my head. I'll make a temp pointer and I'll store all the nodes in my DQ. I'll make a head point towards, I'll just reassign. I have just pushed it all into my DQ. I'll just reassign my temp to head. Okay, while my queue is not empty, what I can do is, if my I %2 equal to 0, basically, then this. So if I is 0 at this position, okay, so I have to pop from the front, but before popping, I have to get access to it. So I'll get access by q.front. Okay, this will give me access, and I'll just pop it. Why I'm popping it? Because if I don't pop it, basically if I don't pop this one out of this list, then I'll again get access to this node, right? So yeah, I have to pop this so I can get access to the second element. Okay, second element. Else my t is equal to q.back. Okay, q dot pop underscore back. My t of next equal to null, temp dot next equal to t, and my temp equal to t I plus plus. Okay, I'll try to run. Successfully ran, and I try to submit. Successfully submitted. Okay, so if I try to explain you the code, basically I am just storing, or I am just declaring the edge cases. First declaring edge cases, then I'll just storing all nodes into the deque, then I am just traversing through the nodes in the queue, in the deque, basically deque alternatively, starting from the front and alternating respectively. Okay, so I'll first start from the front, because I have to get the first node first and then the last node. Okay, and what this I am doing is basically I am assigning all the nodes, all the I'm just connecting the first node. I'm just connecting the first node. Basically, this is the front node, this is the back node, front, back, then front, then back. I have to connect them all, right? I have to connect them all, right? So this temp will be pointing to a newly made node. Okay, and then I'll just push this temp to the next position. Basically, if my queue, basically if there is one present, then there is two present. Okay, I'll just pop this out. I'll get access to it. I'll push it into a list. My temp points here. Okay, and when I'll get access to this, basically it is t. I have to make it pointed to the two, right? I have to make this pointed to the 2. Okay, and as I am done with this, I'm just relocating the temp to t. Okay, so this is what I am doing, and I am basically increasing my count. Okay, so if I get to know about the time complexity of this, basically I am just running one loop for storing all the elements in the deque, and I am just running another loop for the queue. Okay, so my time complexity is somewhere between 2 raised to power n. Okay, and my space complexity becomes O of n, as I am using a queue, deque basically. Okay, so this was all about the solution of the question reorder list. Okay, if you have any doubts regarding solution, you can just ping it out in the comments, and if you like the solution, just like, share, subscribe, and have a nice day. Goodbye. Bye bye.